All right, before we get started on the last notes in Chapter 3, if you guys could take a moment and pause the video and solve this warm-up, which is a review of our crook problem. Remember, assuming that the top and the bottom lines are parallel, we're going to draw in parallel lines that go through those points. So I'm going to draw in another parallel line over there and another parallel line over here. And that's going to split x and y up, not necessarily evenly, but it's going to split those angles up, and we're going to use our properties of parallel lines. So first off, I have an equation already because I know that these two angles that are forming a linear pair must be supplementary to one another. So that's one equation I have. Now I'm going to use my properties of parallel lines. So I know this 40-degree angle and just this top part of x are both 40. And then I know if I have the entire angle is x and I take away 40, then I know this bottom part is going to be x minus 40. I can do the same thing down on the bottom now. If I have an angle of 30 degrees, then I know its alternate interior angle, again because of the parallel lines, is 30. If I take 30 away from the entire angle of y, then I know the top part is y minus 30. And then again, between these two parallel lines that I drew, I have x minus 40 and y minus 30 are alternate interior as well, which means they are congruent angles. So now I have my system of equations that I'm going to set up. I need to move my x's and y's to one side and set it equal to. So when I simplify the top one, I get x plus y equals 110. When I solve the second one, I get x minus y equals 10. And my y's are going to cancel, so I'm going to get 2x equals 120, which means x equals 60. And then when I plug that in, I'm going to get y equals 50. We've practiced writing equations of lines, so today we are going to add in the writing equations of lines with parallel and perpendicular lines. Find the coordinates of point F along the directed line segment CD so that the ratio of CF to FD is 3/5. So there's going to be a point somewhere along here, doesn't matter where, we'll just call it, pick a spot there, where the ratio is 3x to 5x. And that's where our point F is going to be. We don't know what it is. So when I find the slope of the line, plug in my original ordered pairs for the slope of this line. I get negative 2/3. Now looking at my y and my x here, so for the 3/8 of the part to start from each spot, if I want to go from C to F, it's 3/8 of the part. So -8 times 3/8 would give me -3, and 12 times 3/8 would give me 4.5. So since C is starting at -4, 5, that would mean that applying this these ratio factors, that would mean that I need to add 4.5 to my x and subtract 3 to my y, which would give me an f value of 0.5, comma 2. This part is a little bit of review. We've talked about how parallel lines have the same slope. So when we find the slope of one, obviously we'll then apply that same slope to be for the other line. When we are looking at perpendicular lines, it means that when you multiply their slopes, they have a product of -1. And what that's saying is that these slopes are opposite and reciprocals. So for an example, if I told you that there was a slope of 2/5, then the perpendicular slope to 2/5 would be the opposite is negative and then 5/2. So in order to determine whether the lines are parallel or perpendicular here, we need to find the slopes of all of the lines. So go ahead and take a second here to plug in the ordered pairs along each line. They're color-coded here, so the blue, the green, the purple, and the red. When I plug in the points for the blue line, line A, I get that the slope is -3. When I do it for the green line, which is the blue line, the slope of line B is -3. When I do it for the purple line, which is line C, the slope of C is 1/3. And then when I do it for the red line, which is the D line, the slope of D is 5/8. So when I look at these slopes, A and B are the same. So A is parallel to B. And then when I look at A and C and B and C, those are opposite reciprocal slopes. So A is perpendicular to C and B is perpendicular to C. Writing an equation of a line that is passing through the given point and is perpendicular to this given line. So first off, we need to find the slope of this given line. So in order to do that, I'm going to put it into slope-intercept form. So I'm going to move the 2x to the other side and the 30 to the other side. And then I'm going to divide everything by 3. Which means my original slope of the given line is 2/3, which means my perpendicular slope, which is what I really want, is the opposite reciprocal of 2/3, which is -3/2. And then I'm going to use my given point, so given point of -12/6 and my slope, and I'm going to plug it into point slope form. Y minus my y value of 6 equals my slope of -3/2 times x minus -12, which is x plus 12. Given the vertices of this triangle, it might be helpful to actually graph this triangle. So we have 0, 6, 5, 8, and 4, -1. Write the equation of the line parallel to LM. First off, if it's going to be parallel to LM, I need to find the slope of line LM. So plug in those points for L and M, and I get that the slope is 2/5. If I want the slope that is parallel to 2/5, it's also going to be 2/5. I then need to use point N. And point N is 4, -1. So I'm going to use slope of 2/5, 0.41, 4, -1. If I want to find the equation of the line that is perpendicular to LM, I first need to find the slope of LM, which I just did in the problem above, which is 2/5, which means my perpendicular slope is going to be -5/2. Still using point N, so this time it's y plus 1, but it's -5/2 times x minus 4. Next problem is reviewing the distance from a point to a line. So we need to remember this formula. And we need to put this equation of the line in standard form. -2x plus y, bring the 4 over and set it equal to 0. And then I'm going to use the point 6, -2. So that is my x and my y. That's my a. There's a 1 in front of the y is my b. And then 4 is my c. So just plug those numbers in now. And you're going to get 10 over the square root of 5. And then we are going to multiply the top and the bottom by the square root of 5. And we're going to get 10 root 5 over 5, which simplifies to 2 root 5. And then last problem, finding k if the line through k, 2 and 7, 0 is perpendicular to this given line. First off, if the slope is 1, the perpendicular slope is going to be -1. So we need to plug these points in and make sure that the slope, when you plug those 2 points in, is -1. So 0 minus 2 over 7 minus k equals -1. And then cross multiply. And the k value must be 5. And then that will be the end of our notes for today.